Olfaction and taste are the two special senses that rely on chemoreceptors. Taste, or your gustatory sense, has the chemical receptors located in the taste buds. Taste buds are distributed all over your tongue. Now here you see the surface of the tongue, and the taste buds are these little bud-like shapes that are here on the sides. Here is another view with the taste bud showing here. There are 5 basic tastes: salt, sour, sweet, bitter, and umami. Umami translates as savory. For years, people tried to do taste bud mapping to show that taste buds were specialized on certain areas of the tongue, but the taste buds appear to be equally distributed over the tongue, with no one area of the tongue saturated with a particular type of taste bud. Your olfaction, or sense of smell, also relies on chemoreceptors. Here the chemicals are in the air and they dissolve in fluids that coat the nasal membranes. It's estimated we can distinguish about 10,000 different odors. Odors are composed of all kinds of different chemicals. The olfactory epithelium is in the roof of the nasal cavity. The mucus is what dissolves the chemical, and the olfactory receptor cells then pick up the signal. There are several cells between the olfactory receptor cells that are supporting cells that do literally that, support them. The cribriform plate was that set of holes in the sphenoid bone, and these olfactory nerves go up through that to synapse with these nerve cells in the olfactory bulb. The olfactory nerve then carries the information to that part of your brain that is responsible for translating those nerve impulses into smells. The olfactory cilia are embedded in the olfactory mucus, and they increase the surface area. Now, the olfactory cilia are really the dendrites of the olfactory receptor cells. These are bipolar neurons with one dendrite and one axon. The olfactory receptor cells are replaced about every 30 to 60 days. These basal cells are the cells that can replace them. So these bipolar neurons go up through the cribriform plate and synapse with the neurons of the olfactory nerve.